Hello to all. So today we will be discussing the internal treatment methods which are available for treating the impurities which are there in the water which has been fed already in the boiler body. So, what is the main advantage of internal treatment? The first and foremost importance is that it prevents the scale formation. The scale formation, which we have discussed in the boiler problem, is specifically causing reduced heat transfer, increased fuel cost. It usually caused localized overheating and reduced system flow, right? The second advantage is that it removes the residual oxygen which can cause corrosion, leakage and failure of the boiler. The third being control of sludge and suspended solids which can cause carryover problems, damage to the boiler and cause foaming also. The last advantage is that it controls corrosion and maintains the pH of the boiler, right? So before proceeding further, I just wanted to explain what internal treatment is in a brief statement. Any of the water which has already been treated by the external treatment and has fed into boiler body, but we have to remove the anions, cations which can cause boiler problems further, but yes, they have to be removed in the form of sludge because this do not get removed in the external treatment, right? As we have seen in the external treatment, lime soda method, zeolite, anion cation exchanger, we remove the maximum impurities from the water, but yes, the to a certain extent some of the impurities not get eradicated from the water and it will be removed in the internal treatment. Okay, so now what is the main functioning of internal treatment? Here what is the basic principle? The problematic ion has to be removed. How it will be removed? The original property of the anion or the cation will be converted into the inert character. Now what happens here? The problem causing ion reacts with any of the complexing agent and forms a soluble salt. Mainly it's in the form of sludge. Now what happens? It occurs by via two process. First, either the scale forming impurities react with the chemical and form sludge, which thereby removed by the blowdown operation. The second process is the problem causing cation reacts with chemical agent and it get dissolved in the water, but yes, it do not react with any of the entity present in the boiler and do not cause any harm, right? Now, what is the type of the conditionings? The first conditioning is colloidal conditioning. Here, the scale formation is prevented by adding of the colloidal agents. Now, what happens is that, let it be that this ion is the problem causing agent. We will create a jelly-like structure over the cation or the anion so that it becomes unreactive, right? How we will do that? We will add in the water kerosene, tannins, starches, synthetic polymers, glue, agar-agar or gelatin, and this reacts with the cation or the anion which is causing trouble in the boiler, and they form a outer layer over that anion or cation. By this what happens? It forms a non-adherent sludge. Basically what happens is that it creates a shell like structure, it covers it. हम क्या कर रहे हैं? हम आयन को एक कोटिंग दे रहे हैं जिससे वो क्या हो रहा है? अनरिएक्टिव हो रहा है. अंदर का जो सरफेस है वो बिल्कुल भी बाहर टच नहीं हो रहा है, जिसके कारण अब ये जो जेली लाइक स्ट्रक्चर बन गया है, इसके कारण इसका बेसिक नेचर चेंज हो गया है. ये स्केल कॉजिंग एजेंट हो सकता था, अब ये स्लज बन गया है. ठीक है. नाउ व्हाट हैपेंस इज दैट the application is for low pressure boilers. How it removes? It can be later on removed by the blowdown operation, right? Now the second carbonate conditioning is there. What happens is that we are using soda in lime soda process continuously for removing the impurities. But what happens when the soda is there, where it increases the carbonate ion concentration. Okay, now this carbonate ion concentration which is accumulating in the water sample can react with calcium sulfate, and it can convert into a non-adherent sticky scale CaCO3, which is the most insoluble salt in the water. And what happens, it can form a hard scale, right? So what we have to do, we have to remove this carbonate ion, right, as it is reacting with calcium sulfate. And therefore what we do, the calcium sulfate is reacted with soda and it forms a CaCO3, right? And this is the sludge. So basically any permanent hardness causing agent which can actually supply calcium or magnesium ions to the carbonate ions which are released from the soda can form CaCO3. So this has to be removed. So basically this will be removed by soda itself. But the later on what happens, the calcium carbonate which is reacted here will form a loose sludge. Okay, so it forms a loose sludge and it will be removed from the blowdown operation. Now what happens is that we use this method in the low pressure boiler only. Otherwise, if the boiler is operating at a high pressure, the soda will actually react and it get converted into NaOH, which can cause caustic embrittlement. The second example where we can see that scale causing salts can cause damage, here MgCl2 is permanent hardness causing agent which reacts with Na2CO3 and it will form MgCO3 and NaCl. This MgCO3 magnesium carbonate is a loose sludge, but yes, this also causes scale also. So this will react with water and then form a loose sludge in the form of magnesium hydroxide, and the carbon dioxide will release in the atmosphere. Now the third example is Calgon conditioning. Here the scale formation is prevented by reacting it with Calgon. Calgon is a double salt. It is Na2Na4PO3 whole 6, where it reacts with the calcium sulfate, which is a scale causing agent. Here what happens, the reaction will happen and it will form a soluble complex in the form of Na2Ca2PO3 whole 6 and sodium sulfate will get released. What happens is that this soluble complex can actually be removed from the blowdown operation very easily. The application is applicable for the low pressure boiler and the high pressure boiler, which is the main advantage of this process, and it does not cause caustic embrittlement also. And amongst all the conditioning, Calgon conditioning is the best one because it forms soluble complexes which are most stable. Okay, so this is the best method. Now coming to the phosphate conditioning, here the scale forming residual hardness causing salts are removed in the form of sludge. How it happens, the calcium and the magnesium ions can react with the sulfate and the carbonate ions which are present in the water sample. Now it can form calcium sulfate and the calcium carbonate in the high pressure boilers. So this will form hard insulating scale. Now how they will be removed? It will be removed from sodium phosphate. So calcium chloride and sodium phosphate will react. If you see this will dissociate into calcium ion and chloride ions, and this will dissociate into sodium ion and phosphate ion. So that sodium ion will combine with chloride ion and form NaCl, and similarly calcium will actually react with phosphate ion and form calcium phosphate. Similarly, if the scale forming salt is calcium sulfate, it will react with sodium phosphate and it will form calcium phosphate and sodium sulfate. What happens is that this will removed by blowdown operation. Now there will be 2 to 3 conditions where we can actually maintain the pH of the boiler also, depending upon what type of sodium salt is actually used. So if we are using trisodium phosphate, it has no hydrogen ions, so basically it is really strong alkaline by nature. So if at all alkaline salt is there, so it can be used in which kind of boiler condition where alkalinity is very low, right? So next is Na2HPO4 disodium phosphate. It is weakly alkaline, so it will be used in boiler where alkalinity is sufficient. And NaH2PO4 monosodium phosphate, it is highly acidic because there are two hydrogens, and where it can be used, it will be used in boilers which have high alkalinity, okay, because acidity is there, so we have to balance it with high alkaline boiler condition. So if we see what is the advantage of phosphate conditioning, it can be used in the high pressure boilers. It will prevent caustic embrittlement, it can create soft sludge, and it can create pH control, right? So this is the main basic four kinds of phosphate conditionings which are there in the internal treatment. Hope you like the video, and I have summarized it in 11 to 12 minutes. So hope it is advantageous for you. Just go through once again at a low speed if you wanted the concept to revise. Okay, take care.